differences between the two and what we offer. So Yogesh, my ask for you would be to stay tuned as we keep walking through this. Okay, so let's talk a little bit about the Trino query engine. There are two different types of nodes when you're thinking about Trino architecture. We have the coordinator node, which is basically the brain of the cluster. It is responsible for looking at the statements, checking the metadata, checking access, managing all of the worker nodes, making sure it has all of the information. And then the worker nodes are actually responsible for delegating the tasks out with the different data sources, getting the information from our different connectors, and exchanging knowledge between each other. So that's sort of how the architecture is structured when you look at the different nodes building up to a Trino cluster or a Starburst cluster. And that's where it's really cool, where you can scale out. You can see we have a worker node that might need to be added depending on the amount of work that we have available. But right now we only need just the 3 nodes that you see in the picture. So let's go through a basic example. Let's start with, this is overwhelming, but this is kind of what it looks like when you send a query to Starburst. We'll start, this is the full picture. We'll break it down piece by piece, but you can see your data sources on the left. In the middle is the full cluster, the Starburst cluster available to you. And then you can see the user over here on the right, as well as potentially your authentication system, either within Starburst or a different system like Ranger. So to get started, if we kind of look at this, the first thing that will happen is someone will submit a query, which is fantastic. You are looking for information, you submit a query, it will go to that coordinator node, the brain. It will get the information from that coordinator, and that coordinator's job is exactly what we talked about. It is the planner of the day. It's like our wedding planner on the day of. It's our day of coordinator. Its job is to make sure everything is set. So it's going to go look at the metastore. It's going to look at the policy. It's going to make sure you have access to that data. It's going to check that the SQL syntax is actually correct before actually just shipping it off to the worker nodes. And it's going to check you have access to the data sources. It's going to do some basic computation. And once it checks all of that information, it is actually going to do the crunching to figure out the best way to run that query. And then that coordinator node is going to send the tasks that it needs to down to the worker nodes. So it's going to assign out, I need you to do this, delegate out the responsibilities for the day of or what it needs. And then the worker nodes are going to go gather that information from the different data sources that it has, bring it back, check off its task, and then the coordinator node will pull it back all together and send the results to our end user. So that's kind of the gist of it. Definitely can get more complicated than that, but that is our simple 5-minute version of how the architecture works. Trino is really cool because it has, again, a lot of cost-based optimizations already built in. And, Starburst has done a lot to extend that as well to make it even better, with things like result set caching, which is only in Starburst, so that it would cache a query coming in, so you don't have to rerun it and redo this compute. Other things like workload management, different things that we can do to help make this process even better, which, to Yogesh's point, is one of the things that you don't get in Trino that you would actually get in Starburst, which would save you in the long run. So we've talked about this. A lot of companies have used Trino as their query engine. Specifically want to call out, Netflix, when they developed Iceberg, actually developed it for Trino because they were using it. So really awesome information here, of all the different companies that have used it. So you can see the Facebook logo, the Lyft logo, Pinterest, LinkedIn, Netflix, and some of the stats that we have available. But we also know that Trino requires extensive resources to be run successfully. So, for example, that considers the management piece of being able to, there's no auto scaling involved. There is no being able to tailor the cluster to your workload. If you have to change a cluster right now in Trino, you would have to completely restart it, versus in Starburst, you can just update it and get more information from it without having to restart it. And then a lot of that, there's also the security implications. Trino was not necessarily built with security portion in mind. It was mostly left up to secure outside. And Starburst has become that secure layer. We offer different options, including attribute-based access control and role-based access control to secure your data. And we also have support. So like I mentioned, we have the most experts in the world, and we are really excited to offer that to anyone who uses Starburst. So my favorite people are on the pro serve and support team. So I'm a big fan of them, which all takes money, time, effort, and energy, which you could be using to actually build other data pipelines or whatever else you may need. So with that, let's talk a little bit about Starburst. Because we've talked about the Trino part, let's talk what Starburst has to give you an offer. So, we mentioned this. I'm just going to run through this briefly. So we have the data lake. First, we have the data warehouse or data warehouses, but we have the data lake where we can see the awesome capitalization on low-cost object storage. We see the greater flexibility, but the data lake came with some bad things where it was really difficult to get that top-tier performance. There was a lot of data quality and inconsistencies in data formats, not any data lineage available, and it was really bad in transactions, updates, and modifications. So we also see the data lakehouse as the next step, which is sort of that up leveling, which, like we mentioned, utilizes the separation of that storage and compute, applies the reliability, the performance piece, adds data quality, the data quality of the data warehouse to the scale of the data lake. So you get the best of both worlds, increasing sort of those performance and scalability requirements previously not possible. And it allows you to tackle more semi-structured and data as you have in the data lakehouse, a lot of those JSON files, things like that, creating a place for more of those AI, ML, and BI use cases alike, all within the data warehouse, or sorry, the data lakehouse. The greatest thing about the data lakehouse is actually the ability to apply table formats to your data in the data lake so that you can get the information that you need, but still keep it transactional, right? Which is a lot of things that we wish we had, applying the best of the data warehouse to the data lake. So in 2017, Netflix created Apache Iceberg, which we like to, is a fantastic table format that we use internally a lot. For a lot of our stuff in Galaxy, all of our table formats on the data engineering team are in Iceberg. And so essentially Iceberg helps solve a lot of those challenges with performance, data modification. You can get that schema evolution. You can do the data discovery. You can use those open concepts, either Orc, Parquet, and Avro. And it's been adopted like crazy, especially in the last 2 years. So Trino, I started hearing about it in 2022 when a lot of people were popping up in the Trino community using Iceberg. And like I mentioned, those two communities are pretty tight because it was developed originally for Trino. But those communities, 2022, I started to see talks on people using it in Trino. And since then, it's just grown. We've incorporated it a lot within Starburst, making it, basically our whole idea is to create this Icehouse, or which we call the Open Data Lakehouse, also known as the Icehouse, which is the combination of Trino and Iceberg. But essentially what Starburst helps you do is build this open data lakehouse platform. So you have what you start with is your center of gravity. You've got your commodity storage and your open file formats, which we've mentioned already. And then you have your table format, which is Iceberg. And then you have your compute engine, which is Trino, will power the data lakehouse, Trino underlying within Starburst. And then you have your global federated access beyond the data sources. So the whole thing is like you don't have to just access data in your data lakehouse. You can actually extend beyond the data lakehouse and be able to grab data from multiple different sources. And so what Starburst does is applies that security, governance, and access control layer around it to really give you that full data lakehouse information that you need. So it's not just a data lake still struggling. You can have all of the information, like we talked about, security, access control, all of that, as well as helping to power creating the Open Data Lakehouse platform. And our version of that is what we call the Icehouse. So the fully managed end-to-end open data lakehouse platform, which is a big combination of Trino and Iceberg together. And it is trusted by a lot of different people use Trino and Iceberg. Apple is notorious for using Trino and Iceberg together. And we have a lot of our customers adopting that within Starburst as well to have the managed Icehouse. So Iceberg's fantastic. There is some maintenance associated with actually, the way that the table format is created with the manifest files, manifest lists. I don't have. Lester has a training on Iceberg and a lot of information about the files. So if you have any question about Iceberg more in depth, email me. I'll get you connected with Lester. We can get you a lab on sort of the information there, how to navigate throughout the different Iceberg files. But essentially, we have done a lot to help you in Starburst keep up to date with your Iceberg files, including table maintenance immediately incorporated, which you would have to do in Trino. So just want to pause here. Chris, I see your question. Where is the cache data held? I believe it is held it's only in Starburst Enterprise, and I will get you an answer via email. I don't want to say the wrong thing, and I will let you know. And then Surendra, I have a question interested in Iceberg files. I'll get you that information. From Lester, I'll follow up via email. We also support Delta Lake and Hootie and Hive. So it's not like we don't support anything. It's just we are most focused on the Iceberg side and going from there. So, okay. Let's run in. Trino does support Delta. Well, yes, Delta Parquet, I believe, is supported at this time. But a quick Google might help. If not, I'll give you the answer via email. But I believe we do. I have done a demo with Delta Parquet in Starburst Galaxy in 2023. So I do believe it is supported. Okay, so this is all of the things, Yogesh, that I want you to take into account when you're thinking about the difference between Trino and Starburst. All of these things on the screen are things that you would not necessarily get if you incorporated Trino into your environment. So while we can agree that Trino does have access to the on-prem data sources and the cloud data sources as well, we actually have more connectors on the Starburst side than what's available in Trino. And a lot of them are actually enhanced or optimized so that they're faster, more performant, and give you more information. That's just kind of at the data access layer. We also have streaming ingest and file ingest, which allows you to just ingest your data through S3 or through Kafka, Confluent MSK, anything that you need, you can actually get your data ingested through streaming ingest. We also have all of that security and governance wrapped around it, like access control. We have lineage and observability, which we'll look at today, end-to-end encryption, monitoring and logging, row and column masking. And then on top of the query engine that we already have, we have three different types of execution modes. We have our standard execution mode, we have warp speed, and then we have fault tolerance execution mode. Fault tolerance does exist in Trino. However, I believe it only goes to 3 gigabytes, whereas ours is enhanced to 60. Oh, gigabytes not be the right, maybe terabytes, but it's enhanced version of fault tolerance where it is extensively better over what you can offer in Trino. Our cost-based optimizer, we've done a lot to enhance that as well. You can see we talk about the potentially dynamic filtering. We do automatic auto scaling for you. and a lot of the other benefits as well. There is, we have the Metastore in Starburst Galaxy, which we'll use today. We have materialized view options. We have a lot of the Iceberg table maintenance that I just talked about, and data products and data sharing and global search, which we'll touch on a lot of these portions here today. But what we'll see in the lab is just a portion of all of the benefits that Starburst has over Trino. I encourage you to look at the Starburst First Trino website page if you have more questions about that. And like always, give me a shout. I'm happy to talk with you about it. The other thing that Starburst has done is really invested in our AI space because, we have this, honestly, we had this natural path of users where they were started to get interested in AI, and they were using Starburst for it, because what we realized is that Starburst can give you the right access to the data that you need instantly. So it's powering your AI by creating that data governance, that data access, and sort of that data control. And so I encourage you, if you have any questions about AI, to go visit our website. And we actually have a lot of really, really exciting announcements coming up. I'm going to skip ahead really quick. On this May 28th date, we are having sort of a launch point event, which will talk all about our really exciting AI capabilities. So I'm actually going to send that link in the chat in case anyone wants it. But this will go into a deeper dive into what we're doing today, what we're doing on the AI side, and essentially all of the exciting updates that we have in relation to our AI space, because we know that as companies are evolving, it is really important to give you access to the amount of data that you need. So let me skip back here. We have, as we've been talking to our customers, a lot of people who are using AI in general, we've heard these repetitive problems come up, specifically that data access portion where, AI cannot learn or train what it can't reach, or the data collaboration piece where there's a lot of different projects and it takes an extensive amount of time to get a new tool in or to approve a project, whereas it would be nice to have something that you already potentially had ingrained into your account. And then also that data governance piece where the AI governance models are complex, to say the least, and it's difficult to know who has access to what. So with that, we have taken a lot of that feedback and seen where we can help. Starburst was actually built to address a lot of these same data problems if we remove the AI aspect of it. So, our data access piece, having the Trino engine be basically powered for both data lake analytics and high-speed federation is still one of our key places that you see Starburst shine, where we're able to access data not only in the data lake, but also in MySQL, wherever you need your data, both on the cloud and on-prem. And then we also have the data collaboration piece, which is being able to do data discovery and data products. And then we also have that data governance piece, specifically around your models, your AI-powered data classification, data and networking. So it's really, really awesome. And I'm excited to see more and more. I've gotten a little bit of a sneak peek into what some of our AI team has been doing. It's really, really cool. And I would encourage you to join us for Launch Point. At least register and get the information so that like this event, you'll get at least a follow-up with some of the information and hear more about our AI capabilities. They're really awesome so far. So with that, want to highlight Launch Point one more time. And I encourage you to check out our page, play around on the website, see what the AI page looks like to you. And of course, ask any questions. Some of our capabilities are in private preview. So I'd love to hook you up with our AI product managers, get your feedback. So if you have any questions, if you're an active user or you're looking to learn, go ahead and send me an email, say, Monica, connect me with the AI people. I will. I'm very excited to do so. I'm sure they would love to have a conversation about where you could see AI being helpful. Okay, and so with that, I think it is time to move on to Starburst 101. So I'm going to stop sharing my screen. Oh, actually, let me go ahead and share. This is the project architecture that we're going to be doing today. So essentially, you are a data engineer at Uber for the next hour. Congratulations. We are going to be looking at data that is in the Uber rideshare data information, and we're going to be cleaning and optimizing that data in the data lake. Now, we're going to be building out our own data lakehouse with Trino and Iceberg using Parquet. And we're actually going to convert from Hive to Iceberg because we're going to need to clean and optimize that data. Now, the other interesting point is that we have some of our lookup data that is living in Snowflake that we need to connect to because we don't have all of the information sitting in our data lake. So with that, a lot of the things that we could be pulling information from is in the Snowflake lookup table, so we'll need to do a combination to get the data together. So as we're doing that, we'll clean and optimize our data, we'll apply security, we'll look at the different features you have in the platform for your cluster optimizations, we'll look at, sort of some interactive queries you can run, and then we'll build a data product, which we expect to be consumed by our downstream users, specifically either using their favorite favorite dashboarding tool or ODBC/JDBC connection, anything they need to get the information the way that they want it. We are trying to meet users where they are downstream. So that's a little bit about our project. So we're going to take some of the data, look at it, analyze it. Basically, we're going to count up, we have these NYC rideshare information, and what we're going to be doing is kind of calculating when the most popular rides are for the week and for the month over a 6-month time period so that our marketing team can run plays on deals, right? When do we want to get higher rides? All of that. That's what we're going to be looking at. And so with that, I am now going to stop sharing my screen, get situated over here so I can get the lab guide up. So what I have for you today is the Starburst Galaxy account that I have created. It is my free account, so this is no trickery involved. Everything that you're accessing is just included in your base Starburst Galaxy free trial. Nothing else is needed. So if you've gone past your 30 days, but you have a Galaxy account, go ahead and log in. We would love to give you a try. Everything we're doing today is stuff that you can do with just your basic free account. I have shared the lab guide. Let me share it one more time so that everyone has it. I would love for you to use this lab guide, which we will send out via email, but after the event. But this is the lab guide that we're going to be using from today. Like I mentioned, there is one switch from the email that I sent you yesterday. So I would appreciate if you use this new one. If you don't, that's okay too. I will just send me an email with questions and I'll be like, yes, this is the one place that I made a mistake. So go ahead and do this update. And then I also have, for those who do not have the firewall blocked, put together a gist for you so that you don't have to copy paste from the PDF. So that is here in case you're interested in, or you have the ability to click on it and get the information there. So hopefully you can just copy paste into the query editor versus having to copy paste from the PDF. If you aren't so lucky, we will take our time and answer any questions in between. Okay, so with that, I'm going to share my screen and I'm going to jump in. So I have already done up to page 7 of the launch point, of the lab guide, which is the only thing there is just logging into Starburst Galaxy. So we will actually kick off on page 8 and we'll get started. So I'm going to click on, let me go ahead and share my screen again so you can see I'm going to be double wielding. So I've got the full window shown. Let's see. Perfect. This is my lab guide. So this is the fantastic lab guide that is attached to the chat. It's got all the information that you need. You can see the start. We introduce a little bit more of the purpose of the lab. So as I mentioned, we are going to use pickup data from New York City from January to June in 2015. And we're going to analyze all the information about that. So our whole goal is to actually look specifically and clean up this data in our data lakehouse. And by doing that, we're going to look at our land layer, which is just our our regular layer of, our raw data. And then we're going to have our structured layer, which is our bronze layer, which is that cleaned and optimized data. And then we have sort of our consume layer, our gold layer, which is our final layer ready to be consumed by our end users. We've got sort of our data challenges, which is what is the final. We want to create two final outputs, one for our data scientists to run models, and one for our marketing team, which will answer the final business questions of what is the most popular day of the week for each borough that exists in NYC, and what is the most popular month for each borough in NYC. So do you skip to page 7, hoping that you've done the registration already? If not, don't worry about it. Keep doing it while I'm talking. I believe you'll potentially catch up. If not, play the recording back. Happy to run in with you, and we'll go from there. So I'm actually going to switch to share the query editor, and we'll be able to get going. Sorry, these are always clunky when you got to switch to the live demo. Okay, rock on. Let's go. So to start, the first thing we're going to do is create our Amazon S3 catalog to connect us to our, our data lake, our data lakehouse. So I am going to start by just connecting to S3. So the first thing I'm going to do is navigate to the catalogs page. I'm going to click that button, hit create catalog, and get up to my catalog information. So you can see we have all these awesome catalogs in, awesome data sources that we have in Starburst Galaxy. There are even more in Starburst Enterprise. So I encourage you to take a look at the difference list that's available in our documentation. And I'm just going to click on the Amazon S3 bucket, and I am going to start by inputting our information. So on page 8, on page 9, I've got the catalog name, what I want to name it, which is NYC Uber Rides. I have my description, which is just NYC Uber Ride information for 2015. And now I'm going to add the authentication mechanism, which is the access key. So I'm going to copy paste from the lab guide the access key information that I have available. And that should get me good to go for the authentication. The next part is that you can see on the right, we have sort of our default table format. As we mentioned, you can do Iceberg, Hive, or Delta Lake. I have Iceberg. Our Hootie is read-only, and that is why it is not showing up here. Hootie is read-only, but Iceberg, Hive, and Delta Lake are fully operable. And then we have our fast warm-up option. So you can either click that to get fast warm-up. We're just going to leave it off for now. If you wanted to, you could do that and get it even faster. So our next thing is our Metastore configuration. These are types of Metastores we configure to in Starburst Galaxy, which is we have our own Starburst Galaxy Metastore. We've got Glue, and we've got the Hive Metastore. Let's just leave it on Starburst Galaxy for now. We have, again, different options for you in SEP. So Starburst Enterprise is our sort of Starburst Enterprise is our other offering that you don't see here. Allows us to connect to a lot of our on-prem data sources even more. And that is where you would have more options for your Metastore. This is our managed service offering. So we've got a little bit more tightened up for what we can have you access. Starburst Galaxy, for our default bucket name, we are going to put Starburst 101 Hands-On Lab. And then I'm going to add the default directory name as my name. So Monica-Miller. So first name dash last name, or any specific identifier to yourself. This will just be where all of the files go as we create in S3. And then I want to switch on allowing to create external tables and allow writing to external tables. And I'm going to hit that test connection bucket. And now I'm going to connect to the catalog. Uh-oh. Let's see. NYC contains a legal attribute. Let me check what that is, because we just tested this as I was the hour before. Done this lab many times. Let me go ahead and redo it. See where I've maybe messed up? I believe it might be something in the authentication. Maybe I copied over a space. Let's see what that looks like. And I'm gonna hit that test connection bucket. Okay, there we go. So just copy pasted wrong. Sorry about that. Proof it's live. So this is our page for the catalog creation. What we're going to do is actually just skip this for now. We'll do our role permissions later. And this would be the main portion of this piece would be applying to a cluster, which we're going to do our own cluster application so that I can take you through all of the benefits that you can have in a cluster. So I'm just going to hit set permissions and add to cluster. And I'm going to hit do this later. So we are going to do that later. That gets me to page 12. So we're flying through this. We, a lot of screenshots to get connected. And what I'm going to do is re-hit that catalogs button. And you can see some of the catalogs I have available here. And I'm going to re-hit that create catalog. So I am back to the create catalog screen. If you're lost, you can also get there here from the data portion, go to the catalogs page, and you should have your NYC Uber Rides catalog created. And now we're going to create our second catalog, which is our Snowflake catalog. And that is just going to be using the AWS cloud provider. And then we are going to copy the name taxi zone lookup. And I'm also going to copy the description, which says it's a lookup table containing information for the NYC data. Now we're going to keep the the connection type as connect directly, and we're going to add in the Snowflake account identifier as seen in the guide on page 12. And then we are going to authenticate with the key pair. So this is just a reminder that all of the different authentication methods for this will be available until May 14th if you want to come back and do the lab later. So my username here is actually pubkeyuser. And then we are going to copy that whole private key, including the information at the top, which says begin private key, and at the end, which says end private key. We're going to copy that. I'm taking out the space because I get paranoid about it. And then we have our key information there. I'm then going to add the database name as NYC Rideshare. I'm going to add the warehouse name as Starburst 101. And I'm going to add the Snowflake role as Starburst 101. So now I'm going to hit that test connection bucket, and I'm going to connect catalog. Same page that we had on the previous one, where this is the information for connecting that catalog. We really here, they wanted to add to a cluster, but we're going to skip. We're going to leave it blank for now because we're going to create our cluster to add the information. So I'm going to set the permissions and add to the cluster, and I'm going to hit the do this later button. That way we can build our own cluster, which has both of our data sources together. So here we go. We have our catalogs page, which I just navigated clicking the catalogs button. If you're lost, you can do that again by going to data in catalogs. And here you can see we have two new catalogs created. The taxi zone lookup catalog, which is our Snowflake catalog in our AWS region. And we have our NYC Uber Rides catalog, which is our AWS catalog, also in the US East Ohio region. Now that's important to hear because for our free tier, we do not do cross-region, but if you are interested in cross-region, that is something we could potentially upgrade you to. So go ahead and shoot me an email. I'm interested in cross-cloud communication or cross-cloud, cross-region querying, and I'll get you connected with the right product manager there as well. So we've got our information. We are ready to sort of create our cluster. So our catalog is our data source connection. So as you remember the query architecture we're going through, and this is the data sources we will connect to pull our information back. Now we need our cluster. We need our nodes to actually power everything that we have going on. So I'm going to navigate to the admin console, go to the clusters button, and I'm going to hit this create cluster. So in this case, you can see right off the bat, we talked about cluster sizing. There's different cluster sizes available for each. We are going to be using just the regular free cluster, which means that we have a one node coordinator and worker combination. So we only have our coordinator node, our one available to us. You could actually use the option to scale this up or click auto scaling enabled if you wanted to give it more power. And that is sort of that scaling capability that we allow using the power of Trino that we've built on. So just wanted to call that out here. For our free cluster, we are just, using our regular information and going from there. So skipping to page 16, I have navigated. I'm going to do it again just so everyone can see. If I'm on the catalogs page, I've navigated to the admin side and I'm going to the clusters pane. And I'm actually going to hit that create cluster button. Now I've got my cluster name, which I need, which is NYC Ride Info. And then I've got my catalogs, which is going to be selecting the two catalogs I just created, NYC Uber Rides and Taxi Zone Lookup. Like I mentioned, that's going to live in our US East provider region. And we can have the information here. I'm actually kind of curious if this query results with caching button answers our question on where it is stored. Cached, the result is cached for a specific time period. I'll have to read into it and get the information there. But let me just send that in the chat for anyone who asked about the results at caching portion. Okay, so I'm back here looking at the query result caching. You can see we also have uptime options. These are, again, because we have our free version. And then we have our execution mode. So I talked about different execution modes being available so that you can tailor the cluster to your workload. We have our fault-tolerant execution mode, and then we have our accelerated execution mode, which actually speeds up your data lake queries using warp speed, which is our proprietary indexing and caching layer. And the whole goal here is to basically tailor the cluster to the workloads that you have executing on it. Because we only have our standard option, honestly, that's why we're going to use that today. And also because I think it would be the best for sort of our interactive querying that we're doing. But if we had, sort of a dashboard we were filling in, I would potentially select fault tolerant. Or if we had some data specifically, AWS, and we had some of our large joins, I would potentially flip on that accelerated cluster to be able to get the benefits of warp speed. So with that, I'm going to leave the access as it is because really we're just going to be accessing as the account admin. And I'm going to hit that create cluster button. So I've got my two catalogs. We should be able to see one that's starting up. And if I click into that edit cluster button, you'll see we've got the two catalogs connected. And we've got what we need with query result caching. So this is all warming up. We've got the information. You can click in here, see the catalogs, the region provider, all the information about the cluster, and we should be good to go there. So now what we're going to do is actually navigate to the catalog page again. And we're going to do that because we're going to be using schema discovery. So I'm going to go to this catalogs button. I'm going to click on my NYC Uber Rides catalog. And you can see we have all of the metadata information around. For even the free users, we've got a lot of information around our specific catalog that we have connected here, our data source. We've got the description, we've got the Iceberg default data type. We can add an owner, we can add a contact, we can add our tags for our attribute-based access control. We could go in and add whatever tag we wanted to. The thing we want to do next is actually navigate to schema discovery, but you can also see here, we'll play with these a little bit later, looking at the different options you have throughout, your metrics, your quality. You can build data quality checks in. We have your query history, the audit log, and then also the access control options. We'll play with those as we go through and build our data products. But what we want to do right now is utilize schema discovery. So schema discovery is one of my favorite features because I build a lot of labs. And sometimes I don't necessarily know the full tables we have available or anything. So what I do is I go and put a catalog URI in, and it will pull back the information for me. So what we're going to do is actually look at the page A19 of your lab guide, and we're going to copy the specific URI we want available. And this just speaks to, I know a lot of data engineers spend time trying to figure out where their data lives, and instead of actually doing any data analysis. So What I love about schema discovery is it gets those object storage locations where you can just put in what you want. We could even back this up if we wanted to and get more information, but it helps us kind of put in that URI, and then you can start assessing and manipulating the data without having to go through and know exactly what create statement to put for your entire data. So we're going to leave the default schema as discovered schema, just leave it as it is. And I wanted to show you for the enhanced settings, this one doesn't really matter because we have, this is our first run. So I'm just going to click full discovery, but it would, you're fine if you do incremental discovery as well. But essentially, this is just your type of discovery that you want to do. So if you wanted to do sort of an append to the data, or, instead of doing like a full historical load, you wanted to just do like an incremental load each day, you could allow that as well. So I'm going to hit that run schema discovery button. It's going to do the work for me. It's identified the right number of partitions in my table. I've got all of the information that I need, and then we're going to hit the create all tables button. Okay, great. So we've got our schema discovery done. We can look at the operations it took to actually get the schema discovery up and running. So you can see we created the schema for specifically discovered schema, which we put in. We can see the statement that we used to actually build the table that was completely inferred by Starburst for us, which is fantastic, based off of the data that we had living in our data lake location. And then we also see the sync partition metadata statement, which is based off of some of the Trino operations and our metastore information to get the data accessible for us to just be able to query. So I'm now going to hit that finish button. And I am going to now be able to jump in. I could look at the log. Actually, what I want to do is either hit the query data button or go over here and navigate to the query editor. So now we are actually going to get into running some queries. We're on page 22 of the lab guide. And the first thing we want to do, you might have a, sorry, let me scroll up. You might have a tab here that necessarily doesn't have the information that you want, or you were already playing with Starburst. Go ahead, hit a new tab, and let's go ahead and jump in so that you can have your information. Feel free to relabel it if you want. It's totally up to you. I'm going to select the cluster as the NYC Ride Info cluster. I'm going to select the catalog as the NYC Uber Rides catalog. And I'm just going to leave the schema for now. Don't select a schema, but just look at the information we have available. So we can have our cluster here. You can see our two catalogs that we have available to us. So we've got that taxi information we can see populated via Snowflake. And we also have, oh, look, our discovered schema has put our table in. So what I'm going to do is select this table and click select from NYC Uber Rides, discovered schema, year, month. I want to get the information here. So I'm just going to do that select statement. It's going to take a second to start because I talked for a while. I apologize. I was really excited to show you all the features. So give me a moment. That's because I only have the 5-minute uptime versus I used to be able to put the 15-minute uptime. But my promise to you is anytime I do a demo, I want you to have access to everything I have access to. So that's why I am so diligent about doing it in sort of the free environment. So we're starting the server. Let me see, what else can I talk about? I probably should have saved that for here. Give you a little bit more information for what we'll use later. We'll have our different account profiles that you have on the side. You can have different roles. These 2 roles are available to you. And then we also have our global search button, which you will get later. We'll use for searching for our data. So I've run that query, and now you can see basically our general information. So this is our land layer. This is our raw data. This is our bronze level information where we have all the data available to us, what we've pulled in from the Uber ride. So you can see sort of the dispatching base, the pickup date, the base number, all of the information we need, and then the year, month. So now if we actually run a show create table on that, we'll see in here that it's the same table creation, the DDL that we had when we ran schema discovery. should be obvious, but just kind of to illustrate the point, or like that, this is showing you the exact same information that we automatically picked up as Starburst using schema discovery. Now we can verify the schema in the catalog. You can look and see where it is available. And what we're going to do now is go into building our data lake. So on the first part, we're going to we've already validated the bronze layer. So we're actually going to skip ahead to page 25, where I told you earlier we had 6 months of data. And so our goal here is to actually make sure we got all 6 months. This is just running a quick sanity check here to do a little bit of data validation to make sure all 6 months picked up from that schema discovery. We can see we have all of the months available to us, so that's great news. We're able to continue on and get fair analysis for our data analyst, our marketing team downstream. And so with that, now we're going to build in our data lake. We're going to build in our data lake house. This is our, our regular bronze level. We're now going to do our silver level, which is sort of that cleaned and optimized layer in our data lake house. And I'm actually going to turn that into the data product for our team later downstream. So I've got on page 26, what we need to do is create a separate schema so that we can turn it into our data product. So what I'm going to do is just copy the lab information, which says create schema, NYC Uber rides, and I'm going to replace your name with my name. Go ahead and replace it with your name. And this is just going to create a schema for us to operate within, like I said, that can be turned into our data product. So I'm going to hit that run button, and we're going to get our schema created. So if we refresh on the left-hand side, we'll see we now have 3 schemas, sorry, 2 created schemas, discovered schema, but we now have this other schema with my name that we can build tables in. I verified the schema in the catalog, so that makes me skip to page 27, where I can actually put the selection of my schema. So I'm going to hit the select schema button, go down to Monica Miller, and now it is time for me to rock and roll. So I can put in my queries for later. So I have the build the silver layer information. So we've talked about our bronze layer, our land layer. That's our raw data that we just saw in our schema discovery. Now we're going to move on to our silver layer, which is data that we need to clean and optimize. So if you noticed in the discovered schema, we had Hive, DSB, not formatted at all. We're going to transform that data into Iceberg, Parquet, and clean it up into what the type of data that we want to use going forward. We'll also be joining that data with data that lives in the taxi zone lookup so that we can get the information. This is in our gold layer. We can get the full information for our downstream consumers. But first, let's do that cleanup on the raw bronze layer. So we are going to actually, now that I've selected my schema up here, that's extremely important. If you get an error, it's probably because you didn't select up here. We're going to copy the create table command on page 28. So I'm going to run it and then we'll talk about it. You can see here that we have our create table statement, which has all of our different columns that we want, specifically with the type Iceberg, format Parquet, partitioned in the year-month array that we want. And now we're going to run a command to actually copy in or insert into the ride pickup table that we just created using all of the transformations that we want, casting some of the data types. So I'm going to again run it and I'll talk about it. So you can see we're inserting into our newly created silver table all of the different data we have available for us. We're casting some of our different pickup types. We're using the discovered schema year month. And you can also do this. So we did this as like a separate step for the insert into, which is strictly just because we were doing kind of to demonstrate what we're up to. If we wanted to, you could also do a create table as statement, so you wouldn't have to do 2 separate steps. And we are doing the full historical load right now. You could do this incrementally, so you could insert into, select, make a query to do it from the last 24 hours, the last month, anything like that. Look at the incremental loads, and you can use your favorite scheduler in conjunction, Airflow, Prefect, Dagster, anything you want. We also have a scheduled jobs feature, which would allow you to run SQL on a schedule. If you go into some of the, I believe it is jobs feature. Let me open that link in a new tab. And you could actually create a SQL job to automate. So you could run that here as well without having to go into your favorite scheduler. So with that, we've got our data inserted into our silver table. So if I reopen, we won't see no content anymore. We'll see ride pickups. And we've got our clean data. So let's just validate the silver table by doing a basic select statement, which is available on page 28. Here you see the data looks extremely similar to what we had before, but if we actually do a little bit of looking underneath, you can see that these are now iceberg tables, which I'm copying the 3 tables over on page 29, where we can actually look at the history. Let's start with the history. You can see that we had the first snapshot of creating the table, which is also why I did these 2 commands separately so we could see them. You have the create table and then the insert into statement, and then we can also see the 6 different partitions. And we can also see the snapshot. So the whole point here was showing you that these, while the data on the outside might look the same, they are now a lot more optimized in a sense, built into Iceberg format. So we can do our table maintenance going forward and keep our data up to date. So just wanted to kind of show that out. And like I mentioned, there's a link in the lab guide to an awesome hands-on Iceberg lab, but I know there's someone else in the chat that I have to get in touch with Lester for their metadata management lab for Iceberg. But if you have any questions on that, go ahead and let me know. I'd love to point you in the right direction. So our next step is to federate your data together. So I am going to actually run a query that's on page 29, which will connect the top 3 are referencing the ride pickups table that we have right here in our AWS data source. And then our last 2 are referencing the taxi zone information that we have in our zone lookup using Snowflake. So we're able to do one SQL statement, join the data from 2 different locations without doing any other additional work, and get a result back that we can then apply into a view, a materialized view, anything for our team downstream, which would save a lot of time and effort and energy from some data engineers who, an analyst, like I used to have to move data from one database to another just so our data analyst downstream could join 2 tables together. This would have saved so much time for us to be able to do that instead, or honestly empower the analysts to run their own queries. That would have saved us so much time. So now we're going to navigate, now that we've got our SQL statement that we know we want to use, this is what we actually want to build our gold layer with. Like we want to use this to build our final table so that we can then build views on top of it and get our data in a data product format where it's stamped and ready to go. So I am going to navigate to page 30, and I am going to copy the gold table creation statement, which is right here where it has rides by zone. You can see we have it as an iceberg type format parquet. And we actually do some little bit of data transformations in there for our final version. So this is our final stamped data that we want, and it's actually combining data from both sources. And I'm going to hit that run button. And this is sort of like that create table as statement I was saying. I wanted to show you both. But here, you could do like an insert again of insert data from the last 24 hours, or insert data where came in from the last 24 hours or came in from the last month, or where month equals, and we could put the specific month that was being added. So it allows you a lot of flexibility to sort of incrementally load that data. And you can now see we've got that successful. And I'm just going to run a simple select to show you what this one looks like, which should look above very similar, but we'll add those 2 extra date format columns. So now you can see we have our weekday pulled out and extrapolated from the pickup date, as well as the month. So it's doing that conversion so that we can then build our creation for our views on these 2 new columns. So combination of pulled data from AWS for these first 3, we've created these 2 columns, and then we've pulled data from Snowflake for these last 2, all within one table, which is so cool. So much data accessibility that's available for you, but that we previously wasn't thought possible, or at least when I was data engineer, I didn't think was possible. So the next thing we're going to do is just run some interactive analytics on our data to see how we can get our. I'm just going to add some extra rows here so we can see it in good force. But basically, we're just going to copy the command on page 31 of the lab guide, which is going to be doing a with statement within basically doing a window function to look in for the marketing team, run a subquery so that we can pull in the specific weekday is most popular. So you can see we're selecting the specific information, doing that window function, and pulling in only the three different columns we wanted, selecting the top column. So I'm just going to hit that button. And you can see we can have the total rides for each with each borough, each weekday, which weekday is most popular, and the total amount of rides. So this will also give the marketing team perspective of like which boroughs are worth going after at all, depending on their budget. We have all our information here. And we are now going to kick off into our views. And so we're just going to take this exact same statement and add a simple create or replace view at the top so that we can actually sort of harden that view instead of just doing like some interactive analytics. Before I run that, the point what I was trying to show here, which if you didn't get it, it's totally okay, it wasn't obvious. I was trying to show the benefit of doing sort of these interactive statements while you can then flip over to creating sort of that hardened version very quickly. So I used to run interactive statements to do all of my data discovery, and then it took me a lot of time to actually harden that into production. But this will take us a couple of minutes because we'll be able to do the right analysis we need with our SQL. Once we've got that, we can just do the create or replace view and sort of harden that as we need. So I am going to just add that information. I'm going to hit the run button. So we're going to get a new view that will show up in my Monica Miller schema. So we've got our two different tables, our most popular weekday view, and now we can select from that. I'm actually going to skip. We're going a little bit later, probably because of all of your awesome questions. So I'm actually going to skip page 33. What I would do in the past is do this for a different view where we would just do, instead of just analyzing the weekday, we'd also analyze the month. We're going to skip that for now, and we'll just have one view available to us, the weekday view. So next, we've got our full data analysis available. What I'm going to do is actually click over here and hit the Go to View button. So if you didn't see that, I'm going to click on my schema. I'm going to click on the three dots next to my view, and I'm going to hit Go to View. What I wanted to do here is show you all of the metadata associated with the view, but more specifically, you can see your columns. We can add a description. We can add tags specifically to each. So I'm going to add the tag to the weekday that it's the aggregation ID. This will be really helpful for sort of attribute-based access control that we have available. You could add, if we had any PII data, we could add that as a tag, and then we could write a query to sort of take out the columns that have any PII data from specific views. There's a lot of information on access control I can send you if you have questions there. But it's a lot of really great stuff that we have built in, both role-based access control and attribute-based access control. But what I wanted to show here is sort of our lineage. So you can see both the column level lineage and the row level lineage for each of the different tables that we've done in the transformation. So if we zoom in, you can see sort of the different transformations that have for each. You can see basically the SQL transform between to get us to this view from our goal table. And if we back this up even further, we can look at the full lineage to see what happened, to what data transformations happened to get us to where we are. Specifically, wanted to look at one of our derived columns. You can see here that it wasn't here, but it was derived from that pickup date, like we said. So we could look at that weekday column and trace it back. and actually look at the SQL to figure out why. It will also have the version history and all of the information. And it's really, really awesome. It's a good peer into, what you're doing overall with your lineage. And I just love this feature, so I always make sure to talk about it when I can. We also have quality metrics, which we can associate with. You can do a quality check, get information, and my friend Rio just showed me this awesome quality dashboard they've implemented within Starburst Galaxy if you were to actually create the quality checks. And then we have all of our metrics as well, top users, the queries over time, things that we have. So wanted to just kind of peer in there, but as we're going through it, what we're going to do next is actually navigate to the access control section. So I'm going to go to the admin console. Sorry, I'm going to go to the access console, and I'm going to go down to the roles and privileges tab, and we're going to hit the add role button. And so our first role that we're going to create is actually our data science role, because we want to give access to specifically to our data science team so that they can play with the raw data. So I'm just going to copy in the information from page 34, which is going to give this data science role the ability to look at, we're going to later apply it so that we can give the data science team the ability to look at our discovered schema data. I'm next going to add a second role, which is our marketing role, and I'm going to click the name as marketing. On page 35, I'm going to copy in this description, and I am going to hit that grant to creating role button and hit add role. So now I have this marketing role is going to be for specifically the view access that we have from our gold layer. So now you should have those 4 roles. These 2 are automatically there for you. These 2 should have been created, and we're going to assign the privileges. So we're going to start with the data science role. I'm going to actually click on the data science name. I'm going to go to the privileges tab, and I am actually going to click on the add privilege button, and I am going to hit the specific data information. So I'm just going to stay right here, click on the scope button, go into the NYC Uber rides, and look for the discovered schema year month. You'll keep in mind this is our raw data. This is because we want our data scientist team to be able to look at that raw data and run anything that they want to look at or any models they want to do. We're going to give them access to select from that table, and then we're going to hit that save privileges button. We're now going to go to the marketing privileges. So if you hit this back button, make sure you know which role you're in. We're in the data science role right now. We're going to hit back. We're going to go to the marketing button, and we're going to hit the privileges tab. We're going to add a new privilege, and we're going to look for the modify privileges within NYC Uber rides, but we're going to look for that view we created in our gold schema. So I'm going to click on that, and I'm going to allow select from table access. They are not allowed to update, but they're allowed to view that specific table. So I'm going to hit that save privileges button. And now let's go kind of test those roles. So I'm going to go to back. I'm going to navigate to the query editor. And I am going to scroll down to the bottom, and you can see I have the account admin role in the top right now. To the, I'm going to switch that to the, what part are we? We're switching to the marketing role first. And I'm going to see what I can access. So basically, I have this select statement. There's a quick question in the chat about showing lineage. So let me go ahead and go into a different tab. We'll go back in a second. We're going to take a quick detour. I think this is important. If you go into the view in your account admin tab, click go to view, you can then actually click on the lineage available to you. So sorry, I'm in the marketing role. It got confused. But if we go into the view, you can then click on the lineage tab and show all of the different columns available to you. And then you can back that up to see all of the transformations we've done to build it. Okay, perfect. So I'm going to navigate back. It might have I might have confused it. So I'm going to go make sure I'm in the marketing role, and I'm going to select from my table to see if I have access to query. I talked for too long again, so we are going to start up that server. But the basic point here is that we're trying to show the different access controls that you have, even within the role-based access control available to you. There's also we're going to look at the data science role and the marketing role, the account admin role. You can customize this to, it's really granular. So you can get as far down to the table level locations, the object storage locations. You can customize this to basically meet whatever needs you need. And it's a really cool implementation of using sort of role-based access control and attribute-based access control in combination with each other in Galaxy so that you can get extremely granular, like I mentioned. So we just ran this query, and you can see we have the marketing team is able to access it. But let's try as the marketing role to recreate this view. And you can also see on the left here, basically what we're able to see has changed. So I'm just going to try rerunning this query as a marketing person. And you can see we get access denied, which is what we want. They shouldn't be able to create or change or do anything. Now let's actually switch to the data science role. And you'll see our view here is different as well of what we're able to see. And let's see if they can see this phantom view. They can't. But if we scroll up to read from the discovered schema table, they'll be able to see that. So they can read, pull in their data in, and build from there. Let's try doing a command to alter this table, see what happens. So I'm going to copy from page 39 the delete statement, which just deletes from the discovered schema where there's a specific month of September. And it won't let us do that because we have the right access controls in place. So I'm going to navigate back to the account admin role to create our data product. And I am actually going to, data products are so cool because they're these curated package data sets for you for downstream. So I'm going to build a data product, and we'll be able to see it within each different role, how it views based off of the privileges that this one data product, based off of the different roles, what access is granted. So we're going to start by using global search and typing in on page 40 the word borough into global search, and I'm just going to hit view all results. So maybe you know a column, but you don't know where it lives. You can actually go through in here and search all of those results that it has available to you. We know that it's a view and it's a specific column that we want, and so we're able to actually revise it. Let's take out the column option and just look at the view. And we can see we have this view here for us. So I'm going to hit the open details button. And again, we can apply our access control, we can look at our lineage, we can look at our audit log, all of these informations we have available to us. And so I've navigated to this view, but now what I want to do is go up to my schema. Now I'm going to hit the button that says Monica Miller. I apologize for going a little fast here. I want to get it out so that I have the recording for you, so that if you want to work on this on your own, you have the ability. So I just want to acknowledge that you're not crazy. I've definitely sped up, but I want to get you this information one time so that you can pause me if you want to rewatch the recording. So I've navigated from my view to my schema, which I'm now going to go and promote to a data product. I'm actually first going to add some information in here. If we open this up, I'm going to add my description, which is available on page 43. And then I'm going to add a potential link to a data source. So I'm going to name data source information, and I'm going to add in that link. And I'm going to add myself as the contact, so that people know where to find me. And I'll add a tag as far as transformation. I'm going to hit the save button. And now I can actually see a very different view. I can see like my description, I can see links, tags, all of that. You can see we have a tag associated with each of these because we associate it with the schema. And now we're going to hit that promote to data products button. And I am actually going to import all of the metadata we've added. So I'm going to hit that import button. And I'm going to copy the name we have over, which is just NYC Uber Rides Aggregate. And I am going to use the summary and description that's already available. And then I copied the description from page 45. We're going to select the default cluster, which is just NYC ride info. And then we're going to promote that to a data product. So these data products available to you in our screen here will basically give those curated data sets that are ready to be published for downstream use. So you can have someone create a data product. We do this internally. Someone creates a data product for a query that we can use, and then we'll just go ahead and query it without having to do some of the work beforehand. Very thankful to some of my product counterparts who have done some of our queries already that I can just pick up and use. So we've entered our information and now we've promoted our data product. And now what I want to do is just kind of show you what this looks like as a data product with all the different roles. So you can see in my account admin role, I actually have another data product that I have available to me, but this NYC aggregate, I can click into it and we can see the data sets that are available, the tables, the views, the usage examples, if we wanted to add that. You have all this information. But what if I were to switch? So let me go back out. What if I were to switch to the marketing role? We only see the one data product. If we click in on that data product, the data set looks differently. It only shows that one view we have available. It does not have all the information else that we have. And again, if I were to do the same thing with the data science role, we would actually not be able to see the data product, and that's because we haven't granted access to anything in the schema. I might have tricked you. So basically what we did is we did two different schemas on purpose. I'm back in my account admin role to show you that our discovered schema is separate from our data product, which now has a new little logo. And that's why our data scientists could not see our schema. So it allows you, again, that granular access at all of the different levels. It's a really powerful tool. I have a really awesome friend named Adrian Estala, who, if you want to go deeper on data products, he is your data products guy. I'm also happy to dive deeper with you. I think they're really, really awesome. And I even used them before I came to Starburst. So very exciting stuff. Let's look. Okay, so I have a question. Can you quickly show the workflow to get approval of data product access and request is approved by an admin? So let's go into the data products catalog. So I think what you're asking is, I have previously seen where you have to approve a data product. We don't necessarily have that data. We have where you can sort of approve it. We're in the account admin role. So we've just promoted this data product ourselves. I believe you could add potentially checks to get some sort of approval, but mostly the data products are, you can create what you have available. You could then add access controls where only certain people could create data products. That's an option. And then I see another question, are data products shareable across account? There are some that are shareable, so that's in private preview. So this is a different domain, and so it is able to be shared. You can see it has a different domain than anything that I've created, and it is shared with me. So this actually is shared across account, and then our Starburst Enterprise offering does have data product sharing across clusters. That's being implemented, I believe, in either private preview or public preview this first half of the year. I see, Yogesh. We do not have that at this time necessarily for approval, but I would love, to chat if you want to about how that's something that we should consider within our data products roadmap. So I am going to, a data product does need a cluster, yes, so that it needs something to power it. That's why we have the default cluster associated, so that what it's able to connect to. I'm going to stay for a couple more minutes. I want to thank everyone so much for joining. I hope this was informative for you. I want to add my contact information one more time, Monica.Miller at data.com. I've just put that in the chat. I appreciate, again, you taking your time out of your day. And if you have questions, go ahead and send me an email. I'd love to answer. And thank you to everyone who sent something in the chat. I will be going ahead and pruning through those and getting the information that I can out to you. So with that, I hope you have a wonderful rest of your day, your evening, wherever you are in the world. Hope you have a great time. Thanks. And I will send out all of the recordings, the lab guide, all of it will be sent out. So Thanks.